Hey everybody, thanks for joining us here at Meetup headquarters. My name is Andrew Campbell. I'm a technical account manager at LaunchDarkly, and we're here for test and production, our first time here in New York. We've been doing test and production for about a year and a half now. It's our first time here. We recently did one in London, and we want to continue to kind of expand these meetups and kind of promote the idea that your testing environment is no longer needed, and it's kind of a bit of an antiquated idea. I know it was a bit of a cowboy code concept a long time ago. We're really happy to see that it's becoming more and more of a best practice in the world of enterprise. So as usual, if you are a tweeter and you like to tweet things, we would love for you to use the hashtag test in production. Let's think, what else? We're hiring for all positions. We also have an office that's going to be starting soon in New York City, and it's going to be good stuff. We have some of our wonderful new people over there. And what else am I forgetting in my notes? That's right, if you have a phone, this is a meetup. We do have presenters. If you could, please remember to silence your phone because we don't want any distracting noise. And with that, I'm going to hand it over to our gracious host, Lena from Meetup.
Hello, everyone. So I'm Lena. I work for Meetup. I am the VP of Enterprise Technology, which is some fancy term or title. Welcome to Meetup HQ. This is where Meetup is headquartered. We have a little over 200 employees. Most of them are in this building, not necessarily on this floor. This is a space that we use to host meetups. We have our all-hands meetings here, and so we love to have the community here. So a little bit about why I wanted to host this particular meetup, because I love testing in production. When I started working for Meetup, I guess almost 4 years ago, I walked in the door and I took a look at what was going on in terms of how we were delivering software to our customers and in production and how we were doing testing. To put it nicely, it was extremely bespoke and artisanal. It required a lot of manual effort of manipulating branches in Git and deploying them to weird staging environments and weird QA environments. There was no such, we had feature flags, but we weren't using them as a mechanism to launch code early into production and turn it on for actual testing. We were just using it to turn features on and off, for split testing and those kinds of things. And so I knew early on that we had to shift that, and we had to get into a place of doing continuous deployment. And to me, continuous deployment straight in production requires a couple things. It requires a very solid foundation of testing within your testing pyramid, and it requires having feature flags so that you can launch things into production without your users seeing them or without your users being impacted by them, so that you can iterate on them and test them until they're ready. And so we had our own, just like we had a bespoke QA process, we had our own sort of artisanal bespoke feature flag system, right? Which was great for the monolith that we were running, but that didn't scale for us as we were starting to now build more microservices and more distributed systems. So we knew that we had to evolve, and we found LaunchDarkly, and we're glad we did, and it's been a great value to us. So I'm not going to bore you with a lot of details. I want to give you a quick intro. We're hiring too, I guess, but that's unimportant. And I'm going to hand it off. Who's up? Sebastian?
Hello. I'm going to see if this actually comes up again. I've been a user of Meetup for a long time listener, first-time caller, and I've actually been on the platform long enough to have one of my accounts at one point banned from Meetup for reasons that were never clear to me, but it was no big deal. I just nuked that account and got another one, and now I've been using my Weaveworks account now to join up and come to meetups, and it's always fun, and I'm glad to be speaking here for you today. Today I'm going to talk about Weaveworks' progressive delivery system. We actually support an open source project called Flagger that manages progressive delivery in Kubernetes. And one of the fun things about Kubernetes is being able to just get rid of nodes, get rid of pods, repave your instances, and then pull them back up again. But one of the problems with Kubernetes is that you can feel unsure about what's going on in your cluster at any given time. And so at Weaveworks, we're known as the GitOps company. Our CEO and founder is was a member of the technical committee for the CNCF, and we've actually brought Flux and into the CNCF fairly recently, and Flagger is a sandbox candidate right now. So these are the components that are part of the system that I'm working on. I'm not going to read the slide because you can read faster than I can talk. But this is in general. Flux is an agent that runs on your Kubernetes cluster. What it does is it'll look at your Git repo for your YAML file definitions and then compare them to what's going on in the cluster. Anytime they deviate, it will fix it and put it back to what it finds, so that when you want to make a change to your cluster, instead of using the kubectl command line, you'll use Git. You'll check your change into those files. That way all of your changes are tracked in the Git file system. They're hashed. You can audit them. You know exactly who made what change and when. And Flux manages that for you from the perspective of the cluster, so that you don't keep credentials outside somewhere else where they're easier to get, and they're more exposed. The Helm operator is part of Flux. This allows you to use Helm charts instead of YAML files. It's very simple. Flagger is the tool that will take changes that are applied to your deployments. So say you want to deploy a new image of something, it will detect that change, and then it will do a canary deployment for you automatically. We'll talk about that in a minute. And Cortex is our Prometheus-based service. This is for time series databases for showing you statistics, which you'll see how important it is in a minute, because in full disclosure, yesterday, I'm actually working engineer. Yesterday, I managed to completely bork my demo cluster. So what I'm going to show you today is actually broken. So it will be fun. I'll have to have you use your imagination to imagine what it would look like if it actually worked. But this is a diagram that shows what Flux. I'm a firm believer that once you've seen one UML diagram, you've seen them all. And this is really not that different, but you get a sense of how things fit together in the GitOps model. Your user is that, play school looking guy over there, committing changes into Git, as I mentioned before, and those changes are picked up by the Flux CD system and then applied to Kubernetes API and tracked in memcached, so you can keep track of what images are running where, and then those are copied into the cluster and then they run. Let's just pretend that Docker image isn't there because I don't feel like getting into it, but that's basically Flux will also watch your repos to see when you get a new release of an image, so you can decide, you can have it automatically deployed if it fits a certain pattern, all kinds of that stuff. The Helm operator basically does the same kind of thing, except you're using Helm and Tiller to make those changes instead of simply using YAML files in your Git repos. So it's the same idea applied to the Helm and Tiller model. Flagger is the system I'm here to talk about today. In addition to Flagger, we actually have a software as a service hosted platform called Weave Cloud that people will use. They'll sign up for the hosted service that includes hosted Prometheus, hosted Cortex, and that will enable them to monitor Kubernetes cluster from the software, from the platform. Flagger is the component that runs behind that actually will manage the canary deployment for you. And what it's doing is it's using a service mesh that runs in your cluster to manage the traffic that goes between one deployment and another. So say you're running happy service number 1, and you decide that you want to upgrade happy service to happy service version 2. So you start out with your primary, which is running happy service number 1, and you check your change into Git to say, I want to change the image from happy service number 1 to happy service number 2. And Flagger will set up a second deployment of your happy service, which we call the canary. I like that analogy because it sort of brings to mind, the coal miners that go down in the mine and they bring the little canary with them. But in this case, instead of sacrificing the canary, you're going to sacrifice a small subset of your users. Just imagine them laying out on an altar and you've got the knife. And they're the ones who are going to get hit with the new version of your software. Maybe it works, maybe it doesn't. But in this case, you're limiting the blast radius to only those users that you're willing to take the knife to in order to limit the exposure if something does go wrong. So Flagger sets up the two versions of the service, and it uses the service mesh then to direct traffic from the main service to the new service in small increments, say 5% at a time. And then it will increase those increments for a period of time until it reaches a threshold that you define, say 50% of all the traffic. Once it reaches that threshold without experiencing a lot of errors, and you can also set the threshold of how many errors it would experience before it gives up and rolls back. If it reaches that threshold successfully, then it will cut over all of the traffic to the new service, and then that service becomes the primary and the old one becomes your canary. So that's basically the idea. And in this deployments and services, if you're familiar with Kubernetes, the deployment is the thing that lives behind the service that does the actual work. Down here, you've got your Prometheus interface. Prometheus is where all that success and failure, all those statistics go to, and that's part of the thing that I broke. And the Kubernetes API is what Flagger interacts with in order to set up all of these resources. So without further ado, actually, no, there is some further ado. Here are the release strategies that it supports. Canaries, as I said, where you sacrifice a small percentage of your users to see if they're, going to get an error or not. A/B testing, which allows you to switch between positive and negative, and then blue-green, which is the same kind of idea as just a traffic switching. So for A/B testing, you can route different people to different parts of it based on whatever, headers, cookies, the phase of the moon or their favorite color, whatever information you can get about them. Any questions? I know I talk fast. I like talking fast, but there's some ground to cover, and this is really the boring part.
So, I'm not talking actually. So, I was just looking at Flagger, and you guys got integration with Flagger?
Yes. What I'm actually going to show you is I've set up the demo cluster as an EKS cluster. So it's using Amazon's app mesh as the service mate. But we also work with straight Istio and.
Sorry?
You could ask questions on this if you like.
Oh yeah. It's the easy button. You just.
Do you guys also got any plans of having Flagger with ECS or something like that?
Flagger will work with whatever cluster you set up, whatever platform you set your cluster up on. I'm using an EKS cluster because I'm also testing our EKS cuddle tool as one of my functions, and it was just easier for me to use one of the cluster to sort of kill two birds with one stone. But you can do this on GKE. You can do this with your own on-prem cluster. I've seen people run this demo with Minikube. I don't like running it with Minikube because honestly, it falls over more than the rest of the demo is. Even though I'm going to show you the broken one today, it's more likely to completely flame out in the middle of a demo. So I tend to use the hosted platform. But by and large, even just as a philosophy, Weaveworks tends to be very agnostic. So you can swap out different portions of this. If you've got a different service mesh that you want to use, we work with a couple of different types. I've actually got a demo coming up next week with a company called Aspen Mesh that does their own service mesh layer on top of Istio that we're working on integration with. I know I'm spacing on the name of the other main service mesh that's out there, but Istio is the main one, and you find a lot of implementations are based on it.
Linkerd.
Yeah, that's what it is, Linkerd. Yeah. Stefan, who's the main developer, he's in Romania, so he couldn't be here today because that's where he lives, and he gets tired of having to leave there all the time. So, so he actually just fairly recently finished the Linkerd integration, and that was released, I think. Damani, you can correct me, but it was about a month and a half, 2 months ago. Yeah. So this is the fun part of the presentation where I show you my broken system. I'm just going to switch over. This here is our software as a service hosted platform. It's managing your cluster. Three main application portions. Explore, monitor, and deploy. Explore in general, and I'm not going to go too far into this because I want to get to the progressive delivery part. Explore lets you sort of see from a high perspective what's happening on your cluster. That's a graph with the nodes. Here's a graph that shows you your pods. You can filter them based on this kind of thing, and I'm going to show you the Flagger pods. And there's only one, but so it's not that dramatic. And you can dig in to see details about the pods. So you can see the console to get your logs off of it. And I think, oh good, that's not just covered in errors.
So right now your Flagger pod isn't managing anything.
Is what?
So right now your Flagger pod isn't managing anything.
Right now it's not merging anything, it's just sort of sitting there.
Yeah.
My application, as an example application, I'm running something called pod info. And this really just, it's a little web service that just publishes its own version in a pretty little screen. Because I broke my service mesh, I can't show you the screen, but it's basically just for version 2.1, it'll show you a little red screen, and for version 2.2, it'll show you a little blue screen. But that's the general idea, and I'm going to show you a release of that in a few minutes. So the Explorer interface just lets you see from a high view what's running on your cluster, and you can see in this case, we've got 2 containers running in 2 pods, pod info and pod info 2. They're both running pod info D. But if we were to go take a look at the workloads, we would see that within this service we have pod info and pod info primary. Now pod info is the canary, and pod info primary is the running instance in this case. So you can see that 2 pods are running for pod info primary, and there are no pods running for pod info. So what I'm going to do is I'm going to go to our deploy interface. Now you can also do this just with straight Git. If this basically is just sort of an interface on top of the YAML. So rather than actually open up a YAML file and make a change to the file and then check it into Git, this is an interface that will do that for you. It takes a look at the versions of the image that are out there on the image repo, and it lets you pick which one you want to release. So just because it's faster and slightly more entertaining to do it this way, what I'm going to do is I'm going to release version 2.12. This will be our progressive release. And what's going on in the background here is when I hit this release button, the Flux agent is going to check in a change to the Git repository. All it's going to do in that change is change the version number of the pod info image that's running in the pod info deployment. And what's going to happen on the back end is that we have a CRD, a custom resource definition called Canary, that runs in the cluster. And I've set up a Canary instance for pod info, which there isn't really a fun graphical way to show it, but this is in general what it is. This is the pod info Canary description. And you can see it has all kinds of fun attributes to it, which I won't dig too far into. But one of the things that it does is it runs this little command here. This is what's going to beat on pod info to see whether things are going to fall over or not. So you can either use your natural traffic, which is coming from your users, or you can run something like Hey, which will just create load on the cluster for you so that you can tell whether the deployment is going to be successful or not. So going back to this part of the interface, I'm going to hit the release button. And what we'll see here is when I do that, it's going to take me, now this is the brand spanking new pretty portion of the interface that will display what's going on. Normally when we would do this demo, I would just pull up a terminal and then I would exec into the Flux pod, the Flux container, and you would just watch the log files go by. This is slightly more entertaining. So you can see that the deployment has X number of old pods versus X number of new pods that are ready. Right now, what it's doing in the background is Kubernetes is spinning up. It's really just checked in a change to the Git repo, and Kubernetes is now spinning up through the Canary CRD the versions of the new pod. And unfortunately, because of the fact that I broke the deployment, it's not publishing any statistics. What I broke on the deployment, by the way, is the Cortex and Prometheus part of it. Now, because in this demo, it doesn't know how much successful traffic versus how much failure traffic, unfortunately, all my deployments are going to fail. So you'll just have to let me do a little hand waving. But in general, this is what it looks like. and you just have to imagine that it would either succeed or fail. But what happens in the back end is it's actually watching the statistics that get published by the two containers, and then it will compare those stats against your thresholds in Prometheus, which something that would normally trigger an alert, for example, that would go up on your Slack channel, will show up on your pager. This would actually indicate to Flagger whether the deployment has succeeded or failed. And it's going to watch the traffic, and then slowly it will increase and decrease the traffic that goes across the two nodes, the two versions of the pods. And it will increase that traffic by 5% every, 30 seconds, I think, is what it's set to right now. But now, because it's not getting the statistics, it's just going to think that it failed, and so it's going to roll it back. But this all happens for you automatically. If we were to go look at the repo, and I can do that, I can go here into the resources view and go take a look at the history for the pod info container. You can see that this was the check-in that I just did a few minutes ago, the commit. And then what it did was it committed that to Git, it synced that to the cluster, and then the deployment actually has the new version of it. But because the Canary resource was watching this release, the Canary resource said, okay, I'm going to make the pod info Canary portion of it the new version, and then the deployment you'll see actually has the new image tag on it. This is a check-in into Git. That's basically exactly what happened on the back end when I did this deployment. It replaced 2.1.0 with 2.1.2. That's it. This way you know exactly what's running in your cluster at any given time. You know exactly what version was released at any given time. You know exactly who released it. And by the way, this commit is right there on my Git repo, so I can see exactly what happened. That's the beauty of GitOps. It's basically using Git as a single source of truth, which I find very entertaining. I just happen to be a big Git fanboy. So if you were to go into here and take a look at the pod info workload, you can see that the current release version is 2.12, but that version was rolled back. We can also do this again. You can go straight back to 2.10 and run the Canary release. Now those numbers there you can adjust based on whatever version you want. And here you can see a small graph that shows you the weight of traffic that's going back and forth between the primary and the secondary pods. You can see that last release there, it shifted 5% from the primary to the Canary, and then it rolled back because it's not getting statistics and it thinks that the release has failed. Down here, you can see the statistics it's not getting. So normally there would be a little graph there showing you what the request volume would be, and then that would slowly transition from the main deployment to the pod. And that's basically the whole point of it. This here is a Grafana dashboard, which is normally very entertaining to show, but right now is all red because, again, I broke the cluster. So go away, errors. Thankfully, this is just for me to run demos and is not any kind of a production system, because if it was, then I would be yelled at for testing things in production. Not to ruin the theme. That's right. I need a cluster to test the cluster. That's right. And that's pretty much it. That's the extent of the demo. It would be more exciting if I could show you a success and a failure, but unfortunately today I can only show you the failure. Yes?
So this dashboard you were showing, that's a view on top. Wow.
Yeah,
that's something
this is,
on top on Flagger?
Yeah, this is a visualization layer. That's the Weave Cloud interface, and it's our software as a service hosted platform. It's just the reason that I use it is just it's easier to look at and understand than just watching the log files go by.
That's what Flagger is really doing, what you're showing.
Yeah. Flagger is actually doing in the background. It's managing the release. This is really just a visualization tool.
Yeah,
that shows you
so
what's
you
happening in the
can
release.
just manage the whole thing via Flagger, all the JSON. Well, you can really manipulate the JSON.
Yeah, that new interface that I showed you is that Canary deployment button and the little graph there that shows you the transitions. We released that a couple weeks. What's that?
Where you can manage the weights of the traffic.
Yeah, I can show you again the release screen.
Because you are managing the weight to the canary.
I think this should have already failed, so that should be safe to do. And even if it's not, it's my demo cluster. I'll pave it over tomorrow if I have to. Going back to the pod info deployment, if I hit this canary release button, now this is like a feature using feature flags. This is a feature that we turn on and off. Right now, it's only being used by a couple of early adopters who are willing to accept that sometimes it doesn't work. But this is a feature that we've released fairly recently that's a UI on top of the Flagger tool. The Flagger tool just does what I talked about before. All it's going to do is it's going to take a look at when you make a change to the image version of one of your deployments, and then it's going to create that canary deployment for you and use the service mesh to direct traffic between one and the other according to your thresholds and your schedule. And that's about it. The whole thing is configurable. You can change the statistics that it bases its decisions on. You can change how the steps of how much traffic it increases or decreases, and you can change the threshold of when it decides that the release has been successful. And that's all visible here. The max weight is how much is at the point at which it decides its success. The threshold is where it says that the failure is going to be too much. And then this is the minimum weight. That's where it starts, and the step weight is how much it increases or decreases. You also select the version that you want to release. You can roll forward, you can roll back, and then you hit the canary release button and it starts the whole process. Flagger all this is really doing is you're checking in a change to the canary definition, which in itself is also a file in Git that tells the canary release what to do. So this is a YAML file that's pretty much defining for the pod info canary release what you want to release on top of what.
And
this is all defined in YAML. So you don't need to use the UI, you can. It's just that it's much more interesting to look at than editing YAML files.
Absolutely, no, thanks. So, and this file is really the YAML file for Flagger, really.
Yeah, this is a canary custom resource.
Yeah, okay.
Yeah, and this is what Flagger uses to manage that release.
This is the CRD for the Flagger.
Pretty much. Well, the CRD is its own definition, so it's sort of like the spec.
Spec for it.
And then this would be one instance of that.
Okay, cheers, thank you.
Yeah. So that's basically Flagger in a nutshell. It would be more interesting if I could show you a success release again, but unfortunately today I can only show you a failure. But at least you know now that if your release does not go well, Flagger will automatically roll back to you to the previous version, and then you won't have too many people impacted by a release that suddenly starts producing hundreds of 500 errors, which I've done personally, and had to wake up at 3 o'clock in the morning to fix. So it's nice to not have to do that. And here's the pretty Grafana dashboard. This is really just Grafana running in the cluster that I've got a tunnel set up for. And normally you would be able to see some pretty statistics here in addition to the Weave Cloud interface. But today I've decided to make it explode. If you're interested in Flagger and you want to see more details about it, it is an open source project. You can contribute to it. You can read the code. You can find out all about the definitions. And the website is flagger.app. We also have a few tutorials for setting it up on the Weave Cloud website. So if you go to weave.works and go to the documentation section, there's a whole section for Flagger where you can find out all the details that you ever wanted to know and more. And I think that's it. This is another one of those annoying diagrams which describes the GitOps pipeline. So this is the concept of GitOps where you check your changes into Git, and then they get fed into Flux, which get fed into Flagger, which make a change to the canary definition, and then that's managed through the ingress to direct traffic back and forth. The concept of GitOps I find very powerful because I just really like Git. I like the fact that it tracks everything, and then it's sort of its egalitarian code versioning system, and so that's part of what makes me a fan of Flagger and a fan of the Flux component. Flux, by the way, also is an open source component, and if you have any questions about it, I'll be happy to talk.
Yeah, can you explain a little bit about Flux? What's the Flux doing here?
So my favorite way to describe Flux is magic.
What, sorry? Say again.
Magic. It doesn't, what it's really doing is it's just comparing this in the same way that Terraform would, the state of what's on your cluster to the description, the declarative description that you've got up in the Git repo.
Oh, so it's just showing a dev form.
Yeah. The idea of GitOps is applied to Kubernetes is Flux is the operator that makes those changes, but the concept of GitOps can be applied to any sort of infrastructure layer as long as you have a way of declaring the infrastructure and comparing it against what's in the real world, what you've actually got deployed. So rather than actually going and making those changes manually, say you had a Terraform file that was describing how you would set up all of your AWS resources, this would be an operator that compares those declarative descriptions against what you've actually got deployed and then applies them if there ends up being a difference. Prevents you from having drift, and it gives you a way of auditing everything that happens.
And where does it store the state?
Flux stores the state. Primarily, your state is described in the Git repo, but Flux also makes a clone of the Git repo locally that it will use to compare, to make sure, decide whether it needs to pull or not. You don't want it to pull every 15 seconds. Maybe it would be several megabytes of pull. So it also has a local clone of your repo, and then that basically represents the state. To find out the real state, of course, it interacts with the Kubernetes API. We have another one.
All right, so when you're going between different versions, right, is it acting as the primary load manager? Is it relaying it to a third-party load manager, or it's just simulating traffic to one of those?
So depending on what you mean by the node manager, so Kubernetes is actually managing the nodes that are running. So it'll bring up and bring down pods as it needs them. The service mesh actually directs the traffic in between the two versions of the pods. So Kubernetes is really just instructing the service mesh, hey, I want 5% of the traffic to go here, and I want 95% of the traffic to go here, and then 10%, 90%, and so on until
My
it
question
reaches the
is,
threshold.
from the interface you showed, where I can vary load to like this specific version, or you had the small interface where you could,
Yeah.
Is it taking over as the manager for that, or it's relaying it to Kubernetes?
It's relaying, basically. The main port, the Flux itself is really sort of a communication and management agent, right? So the real work is being farmed out mostly to Kubernetes and the service mesh, actually directing the traffic and deciding what goes where. So whatever kind of a switch your service mesh supports, you can generally do within the operator, within the Canary custom resource.
Okay, cool. Thanks.
Nope. Going once, twice, 3 times. Okay. I'll be here all week. Tip your waitress.